Hello everybody. Today we're going to talk about the Cipher cipher. The Cipher cipher is a pretty simple cipher that lets you encrypt simple text by shifting the characters by a certain amount left or right in the alphabetical order that is shown here. And the name Caesar in Caesar cipher comes from the fact that it was apparently used by the Roman military general Julius Caesar when he communicated important information across long distances. And the way this cipher works is you basically map your plain text characters, that is your message that you want to communicate, and you shift the character in that message. You shift the character by a certain amount on the alphabetical order, and then whatever amount it's shifted by, that new character will be in the ciphertext. And here we haven't shifted anything at all, so you see the ciphertext exactly would match the plain text. But another example here where it's shifted by 3 characters to the left, so you can see here that D was shifted 3 times to the left, so every letter A in the plain text message maps to D in the ciphertext, and every letter B maps to E, and every letter C maps to F, and so on and so forth. And as you can see in this cipher, whatever characters were in the very left do wrap around at the very end. So that's how it works here. And in another example where we're seeing how things shift, if we were to shift it by 15 characters to the right, so you can see how A is shifted 15 times to the right, so now P in the plain text maps to A in the ciphertext. We could also say that this was shifted 11 characters to the left if it was to wrap around here, and the A would map from P to A here as well. And that's basically it. It's not a very difficult cipher to use, and we're going to walk through some examples to understand how it works. So here we can have this plain text, let's call it top secret, and you notice the space right here. Well, we don't have any space characters in our encoding scheme. We only have 26 letters of the alphabet, so we would write it like this. And the main reason behind this is that in ancient Latin, where this was used, as I mentioned earlier, Julius Caesar, there were no spaces between characters, right? Whenever you wrote Latin, you just wrote it in a continuous stream of text without any breaks. So if you really wanted to read it, you had to really understand the language so you can pick out the words, right? There was no visual indicator to help you there. So we're going to encrypt this top secret right here, and we're going to shift our characters by 8 steps to the left. So you can see our ciphertext. We're going to change it like this, and you can see how I here moved 8 characters to the left. So now every A character in the message will map to I, and B to J, and C to K, and so forth and so on. So if we were to perform the encryption process, we look at the letter T here, right? So we go to T. T maps to B, so we would put B for our ciphertext here. And for O, it maps to W, so we would put W in that spot right there. And for P maps to X, so we put X for P, and then S maps to A, so we will put A for S. And then E maps to M, so we put M. That's our ciphertext for E. And then C maps to K, so we put K there. R maps to Z, so we put Z for R. And then E and T, we already got those. They map to M and B respectively. And so that is our ciphertext right there when we encrypt the word or words, I guess, top secret, we get the ciphertext BWXAMKZMB. So that's what we get when our message is encrypted. To decrypt this message when we retrieve it, we want to perform the exact opposite process. So when we're trying to encrypt, we shifted the ciphertext to the left by 8 compared to the plain text. So we're going to do the exact opposite here. We're going to shift our plain text characters. We're going to align them to our ciphertext characters, and we're going to shift them by 8 to the right. So we get something like this. Right. So our A is right here, as you can see, when we compare our ciphertext and plain text. Now if we start decrypting, we can see that our B matches T, our W here matches the letter O, so we put O there, and then P matches, wait, no, not P, I'm sorry, X matches P. And then letter A matches S, so we put S there. M matches E, so we put E there. K matches C, so we put C there, and then Z matches R, M matches E, and then B matches T. And now we were able to retrieve our original plaintext. And this is how, it's very simple. This is how the Cipher cipher works. And we don't just have to work with, you know, the 26 letters of the alphabet. We can expand this Cipher cipher. We can actually start calling it a shift cipher, because that's basically what it does. And we can include the space, so now we have 27 characters. So if we did the same thing as our previous example, if we shifted this by 8 characters to the left, we would get something like this, where our space is included as well now. So you can see when we shifted the space to the left by 8 characters, it ended up mapping to the letter S in the plaintext. So if we try to encrypt the same top secret, we would get this ciphertext right here, AWX space MKZMA, and you can see the S here maps to space, which is why there's a space for the 4th character right there. And if we can also include a space this time for our plaintext, because again we added it to our encoding scheme, so we can do that now. And if we try to encrypt this, then we get AWX H space MKZMA, and that H there came from the space. So it's pretty simple, straightforward. We don't have to stop there. We can also add numbers to our encoding scheme, and let's change it up a bit. Let's shift by 14 characters to the right. So A, I suppose, would map somewhere here, so it would map with the letter O. And so you can see our numbers are also mapping to the letters, and if we try to encrypt our plaintext top secret with the space here, then we would get the ciphertext FABME0SDOF. So this is much nicer. It looks a lot more varied. We have numbers in there to mix it up. We can also encrypt coordinates. So since we have numbers here, this is a coordinates for a city. You can find out where that actually is if you like. And if we encrypt this, we get a ciphertext RNUOP yada yada yada. You get the point. That's pretty much how it works, and it's pretty nice and varied here. And this is basically just how the Cipher cipher works. And although this does look like it's pretty different from this and secure, this is quite easy to crack. It's not a very secure cipher. I mean, it's not secure at all, especially by modern standards, because once you know this encoding scheme, you know what characters are being used and what order they're being used, like what order they're being, you know, placed in this table and how many of them there are, then you can pretty much crack whatever ciphertext you have, because all you have to do is just keep shifting it by whatever number of characters are being used. I guess in this case it would be 37 characters in total. So you just keep shifting it by 1 step, and then by 2, and then by 3, and by 4, and so on and so forth, until you shift and get a result that is discernible, something that you can read or understand, and you realize, that's the ciphertext, or I mean that's the plain text. So if you kept doing that with this ciphertext here, if you kept shifting it by 1, 2, 3, 4, and at some point, specifically when you've shifted it by 14 to the right, or I suppose whatever 37 minus 14 is, which is 23 characters. 23 characters to the left, you will see this and you will realize that these look like coordinates, so this must be this plain text. And that's basically how you crack it. It's not very secure, but yeah, that's how the shift cipher works.